Imagine this. It's 1978. You're an engineer at Ford Motor Company. Your team has just discovered something terrifying. The fuel tank on the Ford Pinto is dangerously close to the rear bumper. In a rear-end collision, it could rupture. It could explode. The fix? Just $11 per car. But Ford's accountants ran the numbers. They calculated that recalling the cars and fixing the issue would cost more than settling the lawsuits from injuries and deaths. So they chose not to fix it. The result? Over 500 deaths, hundreds of injuries, a brand destroyed, and a $7 billion hit to Ford's reputation over the following decade. This wasn't just an engineering failure. This was a quality management failure. If Ford had practiced even the most basic principles of total quality management, would those 500 people still be alive today? Stay with me, because by the end of this video, you'll have the tools to ensure disasters like this never happen on your watch. Welcome to Academic Engineering, and today we're diving into one of the most powerful frameworks in all of engineering, Total Quality Management, or TQM. Whether you're preparing for your exams, starting your engineering career, or simply want to understand how world-class organizations operate, this video is your foundation. Before we go any deeper, let's ground ourselves. What exactly is total quality management? Let's break the term down word by word. Total means the whole organization, every department, every employee, every process. Nobody is excluded. Quality is the degree of excellence that a product or service provides, how well it meets or exceeds customer expectations. Management is the act of planning, controlling, and directing, the art of making things happen through people and systems. Put it all together and you get this definition that your professor and every quality textbook agrees on. TQM definition. Total quality management is the art of managing the whole organization to achieve excellence through an integrated system of tools, techniques, and continuous improvement, all focused on constant customer satisfaction. Simple, right? But deceptively powerful. TQM is not just a checklist, it's a philosophy, a way of thinking and operating that transforms entire organizations. Now, if you've been following our quality and reliability engineering playlist from the start, you've already built your foundation with reliability fundamentals. In this video, TQM gives you the management philosophy that drives quality decisions. You're not just watching videos, you're on a mastery journey. Here's an analogy that will make TQM instantly clear. Think of your organization as a symphony orchestra. Imagine you only trained and managed the violins. The rest of the orchestra, brass, percussion, woodwinds, just winged it. Would you get a beautiful symphony? Of course not. You'd get chaos. That's what most traditional companies do. They manage parts of the organization and wonder why the whole thing underperforms. TQM says every single instrument matters. Every musician must be trained, motivated, and aligned towards the same score, which is customer satisfaction and excellence. And here's what TQM asks of every single person in that orchestra. Do the right things right the first time, every single time. TQM is all managers leading and facilitating all contributors towards two objectives. 1, total client satisfaction through quality products and services, and 2, continuous improvements to processes, systems, people, suppliers, partners, products, and services. Notice the two-part goal. It's not just customer satisfaction, it's also never-ending improvement. Quality is not a destination you reach and then stop. It's a moving target that demands constant pursuit. If a company makes a perfect product today but never improves its process, is that TQM? Think about it for a second. The answer is no, because TQM requires continuous improvement, not just current excellence. TQM rests on 3 fundamental pillars. Think of these as the 3 legs of a stool. Remove even one and the whole thing collapses. Let's explore each one. The first pillar is counting, which means using tools, techniques, and data to analyze, understand, and solve quality problems. In TQM, opinions don't count. Data does. Think of it like a doctor. When you go to a hospital, would you want your doctor to guess your diagnosis based on how you look? Or would you want blood tests, x-rays, and lab results? Obviously, you want data. TQM demands the same from engineers. This pillar covers everything from statistical process control to Six Sigma measurements. We speak with facts, not just assumptions. Tools, techniques, and training in their use for analyzing, understanding, and solving quality problems. We must speak with data and facts, not just opinions. The second pillar is customers, and here's something crucial that many engineers miss. The customer is not just the end user. In TQM, you have internal customers, like the next department in your production line, and external customers, the people who ultimately buy and use your product. Every decision in TQM is filtered through one question: does this serve the customer? Remember our basic beliefs. The customer makes the ultimate determination of quality, not your boss, not your engineer, the customer. Quality for the customer as a driving force and central concern. The customer, internal and external, is the ultimate judge of quality. The third and most powerful pillar is culture, and it's the one most companies get wrong. Culture is the shared values, beliefs, and behaviors expressed by leaders that define and support quality. Here's the thing. You can have the best quality tools in the world. You can have the best metrics. But if your company's culture doesn't value quality, if cutting corners is rewarded, if speaking up about defects is discouraged, then all those tools are useless. Culture is the water that all fish swim in. You don't notice it until it's toxic. TQM says leadership must demonstrate quality values, not just announce them. Culture is built by what leaders do, not what they say. So now you know the three pillars, but here's the real question. How did we arrive at these ideas? Who figured all of this out and when? The answer involves a failed post-war economy, a journey to Japan, and one of the greatest management revolutions in history. Let's go. Quality management didn't appear overnight. It was built brick by brilliant minds over nearly a century. Let's walk the timeline. Our story begins in 1911 with Frederick Winslow Taylor, an American mechanical engineer who published Principles of Scientific Management. Taylor's radical idea was this: work should be studied scientifically, not just done by feel. He broke down every factory task into tiny steps, timed each step with a stopwatch, and figured out the most efficient way to do each one. This was revolutionary. Taylor essentially invented the idea that management is a science, not just an art. But Taylor focused mainly on efficiency, not quality. That next leap would come from another genius. Enter Walter A. Shellworth, a physicist and statistician working at Bell Laboratories. In 1924, Shellworth made a discovery that changed manufacturing forever. Variation is the root cause of poor quality. Every manufacturing process has variation. No two products are ever exactly identical. But Shellworth showed that when you reduce variation, productivity and quality both improve simultaneously. He invented the control chart, a powerful visual tool that distinguishes normal process variation from abnormal variation that signals a real problem. We still use control charts today. In 1931, he published Economic Control of Manufactured Product, the first textbook of statistical quality control. Here's one of history's great ironies. The two men who transformed Japan's manufacturing into a world-class powerhouse were Americans. After World War II, Japan's manufacturing reputation was so poor that made in Japan was literally a joke, a shorthand for cheap, low-quality goods. But in 1950, two Shellworth students, W.A. Edwards Deming and Joseph M. Jurin, traveled to Japan and began teaching quality management to Japanese engineers and executives. The Japanese listened. They implemented every principle with relentless discipline. The result? By the 1970s and 1980s, Japanese cars, electronics, and manufacturing were dominating global markets, while American companies struggled to compete with the very ideas their own experts had exported. Meanwhile, in Japan, Dr. Kaoru Isakawa formalized the concept of quality circles in 1960, small groups of workers who met regularly to identify, analyze, and solve quality problems in their own workplace. This was radical. Rather than top-down quality inspection, quality improvement was now bottom-up, employee-driven. By the late 70s and early 80s, the American manufacturing crisis was undeniable. Deming returned from Japan and wrote Out of the Crisis and began his legendary 4-day quality management seminars across the United States. Phil Crosby published Quality is Free, arguing powerfully that preventing defects costs less than fixing them. NBC aired a documentary called If Japan Can Do It, Why Can't We?, which became a watershed moment in American manufacturing consciousness. And Motorola launched Six Sigma, one of the most disciplined quality improvement methodologies ever created. The quality revolution had come home. Now, let's get to the heart of Deming's contribution, his famous 14 points for management transformation. These are not vague suggestions. They are a specific, actionable roadmap for creating an organization committed to quality. Let's go through each one, and I'll show you how each applies to real engineering situations. Point 1. Create constancy of purpose for improvement. Quality improvement is not a one-time project. Organizations must have an unwavering, long-term commitment to improving products and services. Think of it as setting your organization's GPS coordinates permanently on excellence. Point 2. Adopt a new philosophy. Accept that the old ways, tolerating defects, blaming workers, accepting poor workmanship, are no longer acceptable. Leadership must fundamentally change how they think about quality. Point 3. Cease dependence on mass inspection. This is counterintuitive but critical. Inspecting products at the end of production to catch defects is too late and too expensive. Instead, build quality into the process from the beginning. Prevention beats detection every time. Point 4. Do not award business on price alone. Selecting suppliers based purely on the lowest price is a false economy. Low-price suppliers may deliver poor quality materials that cause catastrophic defects downstream. Build long-term, trust-based relationships with a smaller number of quality suppliers. Point 5. Work continually on the system of production and service. Quality improvement is never finished. Continuously improve processes, not just products. Every system can be refined, optimized, and made more reliable. Point 6. Institute modern methods of training. Workers and managers must be trained with the latest techniques, tools, and best practices. Outdated training produces outdated quality. Point 7. Institute modern methods of supervision of workers. Supervisors should help workers do better work, not just monitor output. Leadership means enabling people, not policing them. Point 8. Drive out fear. When employees fear punishment for speaking up about problems, defects stay hidden until they become disasters. Deming insisted, create a safe environment where people feel free to report issues, ask questions, and suggest improvements. The Ford Pinto engineers reportedly knew about the fuel tank problem. Did fear of management consequences play a role in the cover-up? How might drive out fear have changed that outcome? Point 9. Break down barriers between departments. When departments operate as isolated silos, R&D not talking to manufacturing, manufacturing not talking to sales, quality falls through the cracks. Cross-functional communication is essential. Point 10. Eliminate slogans, exhortations, and targets for the workforce. Posting zero defects banners on the factory wall doesn't improve quality. It just frustrates workers who know the real problems lie in the system, not their effort. Improve the system instead of sloganeering. Point 11. Eliminate numerical quotas. When workers are pressured to meet production numbers, they will sacrifice quality to hit those numbers. Quotas drive the wrong behavior. Focus on process quality, and quantity follows naturally. Point 12. Remove barriers preventing pride of workmanship. Engineers and workers want to do good work. When poor tools, unclear instructions, or conflicting demands prevent this, morale and quality both suffer. Remove those barriers. Point 13. Institute a vigorous program of education and retraining. Continuous learning is not optional in a TQM culture. Technology changes, markets change, customer needs evolve. Organizations that don't continuously upskill their people fall behind. Point 14. Take action to accomplish the transformation. All 14 points are worthless without action. Leadership must commit, plan, execute, and sustain the transformation. TQM is not a book to read, it's a way of organizational life to build. Check your understanding. Which of Deming's 14 points do you think is most commonly violated in organizations you've observed? Which one would have the biggest impact if implemented first? Pause and think. Deming's 14 points tell you what to do, but he also gave us an engine, a repeating process that tells you how to do it and how to keep doing it forever. It's called the PDCA Cycle, and it's beautiful in its simplicity. The PDCA cycle is one of the most elegant frameworks in all of management science. It's simple enough to teach in minutes, but powerful enough to drive billion-dollar quality transformations. Think of it as an engine. As long as the engine keeps running, quality keeps improving. The moment you stop the cycle, improvement stops too. Let's walk through each stage. The cycle begins with plan. This is where you identify a problem or opportunity for improvement, analyze its root causes, and design a proposed solution. Crucially, you also predict what effect the change will have and plan exactly how you'll measure whether your prediction was correct. A good plan answers, what exactly are we changing? Why do we expect it to help, and how will we know if it worked? Think of it like a scientific experiment. You form a hypothesis and design the test. Example. A car parts factory notices that 8% of gaskets fail the pressure test. The team plans a process change, adjusting the curing temperature from 180 degrees Celsius to 185 degrees Celsius. They predict failure rates will drop below 2%. They plan to measure defect rates over the next 500 units. Next is do. This is not about rolling out the change to your entire operation. This is about implementing the change on a small scale and carefully measuring the effects. Why small scale? Because if the change doesn't work or makes things worse, you've minimized the damage. You've learned cheaply. This is disciplined experimentation, not reckless full-scale rollout. Example. The temperature change is tested on one line of production for 1 week. Defect data is recorded for every gasket produced. The team documents everything: conditions, measurements, anomalies. Now we check. We study the results to understand what effect the change actually had. Did it match your prediction? If yes, great, the science confirmed your hypothesis. If no, why not? What did you learn? This is where engineers love to live. The check phase is pure analytical problem solving. Example. After 1 week, defect rates on the test line dropped from 8% to 1.4%, even better than the predicted 2%. But the team also notices the new temperature increases cycle time by 3 seconds per unit. This is new information that needs to be considered. Finally, we act. Based on what you learned in the check phase, you make a decision. If the change worked, adopt it as the new standard. Update procedures, train all relevant staff, and implement organization-wide. Celebrate the improvement, but don't stop there. Immediately start the next PDCA cycle on the next problem. If the change didn't work, don't despair. You've still gained invaluable knowledge. Revise your theory, update your plan, and start the cycle again. Either way, the wheel keeps turning. Example, the team adopts the 185 degrees Celsius temperature as the new standard. They update SOPs and train all line operators. The 3-second increase in cycle time is judged acceptable given the dramatic defect reduction. They immediately start a new PDCA cycle focused on reducing cycle time. PDCA is not a project with a finish line, it's a perpetual engine. Every answer generates a new question. Every solution reveals a new opportunity. This is the heartbeat of continuous improvement. Check your understanding. Can you identify a real-life situation in school, at home, or in a job where you naturally went through plan, do, check, act without realizing it? This cycle is built into how good problem solvers naturally think. Let's bring everything together into one powerful idea. Total quality management is the art of managing the entire organization to achieve excellence through continuous improvement and customer focus. At its core, TQM stands on 3 pillars. First, counting. Decisions based on data, not opinions. Second, customers, because quality is defined by the people we serve. And third, culture. Shared values, leadership, and teamwork across the organization. Remove even one of these pillars and the entire quality system collapses. The journey of TQM didn't happen overnight. It began with scientific management, evolved through statistical control, and transformed industries through modern quality movements. At the heart of continuous improvement lies a simple cycle: plan, do, check, act, and then repeat forever. Think of an orchestra. TQM tunes every instrument, every department, and every person to play the same quality symphony. And finally, remember this truth. Most quality problems are not caused by workers, they are caused by the system. Fix the system, and quality follows. That is the power of total quality management. Here's something I want you to think about. Every bridge that doesn't collapse, every medical device that saves a life, every car that brings someone home safely. These are not accidents. They are the products of engineers who took quality seriously. You chose this field. You're here because you want to build things that work, things that matter, things that last. That's exactly who this channel is for. If you're serious about becoming an engineer who understands not just how to build, but how to build right, then subscribe to Academic Engineering right now. Not as a favor to us, as a commitment to yourself. Because every video in this playlist is another step toward mastery. Every concept you learn here is a tool that makes you a more capable, more responsible, more valuable engineer. And don't just subscribe, engage. Drop a comment below. Which of Deming's 14 points do you think is most critical for modern engineering teams? Let's discuss. Share this video with a classmate or colleague who needs to understand TQM. You might just help them avoid the next Ford Pinto moment. See you in the next one.